Okay, well, let's recap the lesson. So we're talking about graphing parabolas, but in general form. So general form is when they have some number, x squared plus a x minus an 8. That's general form. Okay, so we did the first one on Desmos. Here's our parabola. And nice thing about Desmos, you can just tap. There's the vertex, tap. There's the y-intercept, tap. There's one x-intercept, tap. There's the other x-intercept. So I took my Desmos information and I wrote it down. Okay, vertex at -1, -9. The line of symmetry has to go through the vertex, so it's got to be x equals -1. I have a y-intercept of 0, -8. I got that off my Desmos, and then I've got my x-intercepts at 2, 0, and -4, 0. Okay, pretty easy. But what if you can't use Desmos? Well, that's the dilemma. Because when we get to tests and quizzes, you can't use Desmos. You can't use a computer. You can't use your phone. So what do? Well, we have a formula. So if a parabola is in general form, like ax squared plus bx plus c, where a, b, and c are just numbers, but it's in this form, then we're going to use this formula. And it's an easy formula. To find the line of symmetry, it's going to be the formula is x is equal to -b over 2a, where a, b, and c are these numbers, okay? To get then the vertex, we know that the vertex lies upon the line of symmetry. It's an x value. So you take this answer and you plug it into the equation and you get the corresponding y value, okay? So then we took a look at an example, okay? Example 2, and we're going to do it without decimals. So first of all, we need to find the line of symmetry. We used our formula, x equals -b over 2a. So a in this example is 1, b is -4, and there's c. So if I want -b over 2a, I'm going to go a -4 over 2 times 1. -4 over 2 is 2. So I know my line of symmetry is at 2. So I drew that in. Now what I don't know is the corresponding y values. So I plug 2 into the equation. So I plug 2 into this equation for x. So it's if x squared minus 4x minus 5, plug 2 in here. 2 squared minus 4 times 2 minus 5. I wound up with -9. So now I know my vertex is at 2, -9. So graph that. I need at least one more point. And the easy point to get is going to be the the y-intercept. And the y-intercept is when x is 0. Okay, x equals 0. So I put 0 in here, I get 0. Put 0 in here, I get 0. And so I'll get -5. So what we find out is that the y-intercept is just going to be the c value, okay? So I plug that in, 0 and at -5, okay? So then I also have another point because of the symmetry, and I can graph it in, okay? Now we did talk briefly about how to get the x-intercepts. We haven't talked about factoring yet. If you do factor it, and it will factor it, then you can get the x-intercepts. We'll talk about this another day. We're not quite ready for this. But we can get the vertex and a y value, a y-intercept, which gives us a second point, and we have enough to graph it, okay? On the back side of the notes, I just did the same thing, except for, it's just a -1/2. So I still use my -b over 2a, where a is -1/2 and b is -4. So to find the line of symmetry, I went -b, just -4, over 2a, which is 2 times -1/2. That'll sim to a 4 over 1, which x equals -4. So I've got my -4 here. Somewhere along this line of symmetry is the vertex. So I plug my -4 into x. I used a calculator. Put -4 in for x here and here. -1/2 times -4 squared minus 4 times -4 plus 3. I used a calculator. In fact, I'll show you. I think it's still there. Yeah, there it is. I used a calculator, and I got 11, okay? Pretty high up here at the point -4, 11. Okay, so I had to stretch my graph. That's okay. I need one more point at least, and that's the y-intercept, so we know it's at 3. So I put a graph point at 3, and I was able to reflect it for my third point. Now the x-intercepts, I don't really know what they are. I can just guess. It doesn't factor. So if I guess, I thought it was about -9, 0, and about a 1/2, 0. Okay, we'll find out how to find this later. We'll use the quadratic formula later, okay? Finally, example 4. It's a physics problem, but if you throw a rock up into the air, it goes up and comes back down. This graph is a time and height graph, okay? You need negative 16t squared because that's gravity. Always gravity. V0 is how hard you throw it. So you throw it at 48 feet per second, of course, then it slows down. That's what we call it initial velocity. So 48, and that's your starting height of 4. So we have the same kind of equation. I did a little graph, kind of what it would look like, starting height and the vertex. Well, if I want to know the highest height, I need to use my formula. Same formula, negative b over 2a. So there's a, b, and c. I needed negative b over 2a, so put my negative 48 over 2 times my negative 16 for a and b, and then I simplified it, 48 over 32, 48 over 32. I used my calculator, I got 1.5, okay? So I know the time. That makes sense. The time is at 1.5. That's the time. And then the height, I just had to plug it in. So I plugged my 1.5 in for t. So I went negative 16 times 1.5 squared plus 48 times 1.5 plus 4. I used my calculator, and I got 40 feet. Okay, that's all she wrote. There was an assignment. If you need any help, just please come in and ask.